Good afternoon. Thank you for joining us today. My name is Samira Tilley, Industry Marketing Manager at Assemble Systems, an Autodesk company. In today's webinar, we will look at how IMC Construction is using Assemble and Power BI for data analytics through the project lifecycle.
Thanks, Samira. Samira mentioned Senior Product Manager, and that I look after Assemble Systems and other things that we're doing around quantification and estimation. Just a quick background on myself, a degree in construction management from Texas A&M. Spent a number of years in both pre-construction and in site execution. And a lot of that focused around technical implementation, BIM solutions, virtual design and construction, lots of different work around how things were carried through the model, and data was leveraged to push process forward, and actually a lot of what we did were early versions of what you're going to see David has prepared for today. So David, I'll let you go ahead and introduce yourself as well.
Thanks, Tim. So I'm Dave Mazer, Director of Construction Innovation with IMC Construction. I'm in charge of basically continuous improvement in everything that we do, whether it's technology integration, research and development, or just general communication internally to IMC and externally, the different innovations that are going on within our company.
So for those of you that are unfamiliar with Assemble, we offer a lot of different workflows and support data management through models, and that includes Revit, AutoCAD, Civil 3D, and other formats that come through Navisworks. And with that, you're able to organize and aggregate quantities. That's a really key factor in our capabilities that drive analysis of how you organize budgets, value engineering, quantity takeoff exercises, share that data across your team. And then from there, we have the ability to condition that content and add other classification, organization structure, and then query upon that. So Dave's going to dive into a lot of analytics today and how they use the system to set up the data the right way to provide new lens, different ways to look at the project. And so that's a really quick, brief introduction of Assemble. We're going to go ahead and dive into IMC's use case and how they're leveraging Assemble to drive a lot of dashboards. So Dave, why don't you give everyone an intro of IMC?
Thanks, Tim. So IMC Construction is a full-service, best value construction firm in the Mid-Atlantic area, located just outside of Philadelphia. We are the second largest contractor in Philadelphia, and we work on projects that range from retail and multifamily all the way to a $210 million lab project and a $180 million medical office building. So we really have kind of quite the diverse range of projects. We really pride ourselves in innovative project delivery, kind of collaborative project delivery, and really making sure we're providing that best value approach to our owners. The second part of IMC is IMC Construction is part of the Citadel National Construction Group. It's basically a group of regional contractors that kind of get together and work together to serve clients in their regional locations that have national needs. So oftentimes we will partner together to deliver projects for our clients. We get together, we share best practices, we talk about lessons learned, we talk about things that we can improve company to company, and kind of share different resources as well. So it really gives us that national contractor capability as well. So now we're gonna start diving into some of the things that hopefully people are excited about, and really start to look at some of our use of Assemble and Power BI specifically in pre-construction to begin with. So to start, it's kind of important to understand IMC's approach to pre-construction. We really rely heavily on VDC. We have 6 full-time VDC estimators that are in-house creating models, and it's very often that we get scenarios like this. This is a project where we received 4 or 5 different facade sketches just like this of a typical bay. We received some sketches of a typical bay of structure, and we needed to establish different budgets for the core and shell of that project. What we did from that is we produced our own in-house models of those different facade and structural conditions, and used those drawings to go out to the trade contractors, to different suppliers and vendors with detailed quantities and really get some early pricing that we could go back to the owners and really have some detail rather than just a typical kind of cost per square foot based on a single bay. But what we really needed to be able to do was we really needed to be able to kind of take this and expand upon it. So this is one example. The same thing with structure. We will certainly model the structure. We will certainly model the envelope. There may be different design options that we need to consider. So in here we had a baseline structural option A, structural option B. We'll make a model and a sheet for each one of these versions. But the other thing we wanted to do is, if you look at the picture at the top right, how could we compare that hospital project to the one on the bottom? We needed to be able to kind of normalize the data sets between these two projects and not just look at overall tonnage. So it really kind of challenged us to think a little bit differently. On top of that, it's always asking ourselves, like I said, how can we do better? What can we do to improve our process? How do we deal with different data sets? What if we had a project like this that we were receiving models weekly for a year? That's 26 different models. If you've got an architecture, structure, and MEP, that's 26 different models times 5 models. That's over 150 different models and design iterations to analyze. That becomes a lot of different sheets and PDFs to compare and analyze and make sure you're analyzing the data in the same way. So the second challenge another challenge that we had that we were thinking about was we had been using Assemble to really kind of compare some different model iterations, some different design models that we were receiving. But one of the challenges that we had was when we're creating models and we're receiving models, all of the element IDs are changing. This isn't something that's uncommon for us. We'll always create conceptual and schematic models to kind of communicate our estimates, our budgets, but sometimes we'll get DD and CD models from the design team. If you compare these in Assemble, because it's relying on the element IDs, you're going to get that every piece of geometry was added. That's fine for the program, but we needed a way to truly communicate scope change, versus development of the drawings versus just grouping things based on the element IDs. So we really needed to kind of think about a different way to group the information, group the quantities, group things in the way that we needed to communicate to the design team and to the owner.
I think that's key is, you have all of this information and there are a lot of different ways you need to look at it depending on the context of the conversation, who you're talking with, what's most relevant, and how you need to visualize that and organize that content. So I think that's absolutely valuable to have that, that mentality around, okay, this model isn't entirely the right context for this conversation. Let me group and organize just this subset of data and apply that to the conversation. I think that's absolutely key to what you have here and what you're going to be building upon to get to these dashboards that you've created.
Yep. So one of the first things we did as a group and as a team was really sit down and look at what do we model for most of our projects, and then what do we also see in design models. So those are things that we can kind of compare from the beginning to the end if they're in both models throughout the life cycle of the project. And then it was really asking ourselves, what else do we want? How can we do better? Certainly we'd like to get more into tracking MEP, especially equipment, ductwork, major piping systems. MEP is a big component of the project budget, and the more we can kind of track it and control it, certainly the better. The last part is we needed standards and data that we weren't relying on architects and engineers to do the same things and name things the same way. Everybody does things a little bit differently. We needed our own way to kind of normalize the data set and make sure that our templates and standards could apply to any project that came into IMC. So the next thing, I really highly recommend this if you're just getting into Power BI, is we took time and stepped back and really went back to pen and paper, pencil, trace paper oftentimes, and we wanted to understand what data we wanted to see and how we wanted it to be shown. Like I said, we penciled out and sketched dashboards for facade, for concrete, for steel. We started down the MEP route, but we kind of wanted to start simple with the things that we know we're going to get on every single job. It's just kind of it's a quick collaborative process before you really get into the complexities of Power BI, which if you haven't worked with a database program can be overwhelming the first time.
I love this, and I love the interaction you kind of talk about with your team. To me, it's so cheap to work through this on paper and colored pencils or markers like you have here. You can iterate on. You can then share out and actually show others that don't get the the sense of what kind of information can you drill into and why. And I think that conversation, the visual here, leads to why are we doing this? Why are we setting this up? What's the information I can get out of it and drill into? And it's so valuable to have this kind of session and this kind of brainstorming with the visual there to sort of lay things out and understand what kind of input you can get from the team, from your project managers or superintendent or an executive group, and what sort of information you can provide to them. It's so valuable.
Yeah. So the last step kind of before we really dove into Power BI and really kind of creating some standards was mapping out a workflow and really kind of picking the data pieces that we needed to have in order to like I said, normalize every model that we got into a way that we wanted to look at it and a way that we wanted to track it. For now, we started simple. We basically created 8 different parameters inside of our Revit shared parameters file that get applied to every single model that we have. And then from there, it was kind of how are we going to leverage them? What is used in Assemble? What is used in Power BI? What are we sharing with our project managers in the field on their iPads or in different systems? How are we breaking things down by bid package? The FAÇADE one is one that you'll see a lot throughout the presentation here. We like to track FAÇADE. It's a big critical cost component. It's a big schedule driver. It's important to get the building kind of enclosed. There's a couple different things you'll see with that, but this really allowed us to leverage our data in Assemble and Power BI the way our company needed to see it, rather than just relying on Revit category family type, which has really kind of opened our eyes, opened our possibilities in terms of standards and different deliverables to our clients. So the next thing, our workflow is structured to allow people that are not Revit specialists to use the data. That's one of our key things is we want people to leverage the data. We want people to leverage the models, but they don't all have to be Revit specialists. They don't have to understand what a shared parameter is, a text file, and how different things work inside of Revit. But Assemble is fairly easy for them to grasp. You don't have to install software on people's computer. And the biggest thing we want them to do is take template views that we've set up and then move the data from Revit into IMC Construction kind of standards. So this next slide will go through kind of step by step a little bit of kind of how that works. So the key takeaway, and I said it, was we really want people to leverage the groupings that we've set up with Revit views to populate the data. So on the slide before, you saw the example of the Revit structural steel where we have a view that hides everything except lumber, concrete, timber. This has worked for about 95% of the projects that I've experienced to filter that view just to be components that have structural steel. So in one view, I can assign the CSI level, the CSI codes for structural steel, different estimate item names if I want to change it to grouping by level. So first floor framing, second floor framing, whatever it may be, and then I can lump assign all of that steel to one bid package. So in one view, I probably just assigned all the data that I need to in roughly 60% of the structural model elements. The same type of thing with concrete. There's a couple different views that you have to go through, but you open the concrete views, you populate the CSI, and everything funnels up into the IMC views that we have, or the kind of summary takeoff at the bottom right.
Yeah, this is, I think, a foundational thing with Assemble too, is to have a good structure to those views so that, again, those that aren't totally familiar with or comfortable with the parameters and what sort of properties get aggregated to create these views, you can very easily set these up as a template and bring them into each project so that you can, as the facilitator, get your team moving and get the right data sets in front of them.
Yeah. So the next thing was, if you look on the left, you'll start to see kind of different namings than Revit category family types. So this is reporting the estimate line items that we have based on the structural steel for this project. Our ultimate goal is to get that to align with monthly billing applications from every contractor. So these are views that we're setting up for our project managers, for our superintendents, for our owners to see kind of the scope that is being billed and installed every month rather than just how Revit groups things. Again, it's multiple users collaborating on the same data set, how we want to organize the data, not how Revit wants to organize it. Finally, we've organized the data, we've gone through standards. This is the first dashboard that we're going to talk about. So what this is the Power BI version of the pencil copy that we looked at earlier for reporting on the facade. I talked about the facade parameters, so instead of relying on a wall function being an exterior wall or a type name that's an exterior wall, we are literally going in the model, assigning windows, doors, curtain wall systems, different walls that they are, yes, part of the facade, and then what is our general cladding kind of classification of that. This allows us to track kind of critical components, percentages of curtain wall, storefront, etc. What I really think is important is that as you look at this, you understand the data that's behind it and kind of the science behind it about where some of the data is coming from. So on all of our dashboards, we use the Assemble project name, which we have standards for. We have the model version name, which we have standards for, and then comments that just kind of give us an idea internal to IMC about what's in that model, what's not in that model, what's there that maybe we need to know about. This specific dashboard, like I said, it uses an entire page level filter to show just the facade elements. Like I said, we're not relying on a wall function or a type name, family name. And then at the top, if you look at the KPIs that are there for curtain wall, storefront, metal panel, those are all driven off the CSI level 1 and level 2 parameters that we've set up inside of Assemble. So curtain walls, CSI 0843, if I remember right. Metal panels 07. So each one of those reporting kind of cards inside of Power BI has a visual level filter on that specific thing to read the data that we've set up as a standard across all of our projects. So this is applicable to any project that we open in Assemble.
And really quick, you said this model, and I actually saw a question just come in around whether this was a one model, a central model, or federating models. And in this case, we're looking at architectural components, but certainly I think you have other dashboards that combine different models together. So I'd say this is a, federating multiple models that you get from the design team and that you guys are organizing.
Yeah, the nice thing about using the CSI codes as the kind of first level filter on our Power BI reports is we're able to combine elements from multiple models to read the current total takeoff quantity, which we'll see on some of the other dashboards. Yeah,
absolutely. And you can really quickly on that dashboard, you can actually see that you have a table that shows architectural models and the individual versions on the lower left there, and you're using comments to organize those, as you mentioned. So you do have that ability to bring in not only multiple models, but multiple versions, and that's what you're going to get into here in just a minute.
Yeah, so the bar chart at the left there shows all 10 different versions of the architecture model that we've either created or received in the different materials that were on that model at any point in time. So
awesome.
So the next part of this is kind of once we have this data for one project, we want to start collecting it for multiple projects and figure out a way to compare cost drivers project to project. Can we compare overall glazing percentage or curtain wall percentage on 5 projects of the same type? That really starts to become something that you can track and analyze and have a discussion on value engineering or why a project might have a higher cost. So really, again, it's kind of data analytics at a big scale across multiple projects. We're intending to do this same type of thing with structural steel, with concrete, with, like I said, the possibilities are endless. So the next one, this is concrete. So for concrete, for everything that we're tracking it over time. We're tracking total cubic yardage, so we have KPIs at the top again. What is our total flat work square footage, slab on grade, slab on deck? What is our total vertical wall, retaining wall, foundation wall? And then what is our kind of flat work cubic yards? Different things that our estimators wanted to have, our project managers wanted to have, our schedulers wanted to have, just to be able to use in scope reviews, in budget reviews with owners, and then kind of schedule updates as well. So there's a lot of data here, and we've got a few more to get to, so we're going to keep moving. For structural steel, same type of thing. We're tracking total tons, this time kind of back checking against the pounds per square foot that was written into the design narrative from day one. And then we're also tracking what is the total piece count that we have, what is the total linear footage of railing, based again on the CSI 0552 as the filter for that. The stair count was kind of an interesting one for a little while. We had to figure out how to get the riser count to show up as the quantity in that. But if you are familiar with adding parameters inside of Power BI, it's just adding the parameter and changing it to the right kind of data type. But hopefully you're starting to see some consistency in the templates that we've set up, just kind of location of different things and how some of the information is tracked and reported and compared to have our team trained to go to some of the same places to look for the information. So I showed a couple different dashboards there that had a lot of data on it and kind of relied on the data that we're entering. One of the most important things with data analytics is to have a QA/QC process. You have to kind of trust the data that you're looking at. So there's two main ways I review our data in Assemble and Power BI. This is the first one, straight from Assemble's Power BI templates. The only modification that I did to it was on the left side, instead of grouping things by Revit category family type, this is grouping things based off the estimate item name parameter for IMC standards. So this is the way that we're communicating the scope, the quantity in our estimate line items and in those views that our project managers are using. So this is the same way I want to analyze it. I'm just looking for wide-scale quantity changes, count changes. Are there big quantities that aren't assigned to anything? Just a quick high-level way to analyze changes between different model versions. The second part of the QA/QC process that we've established is a dashboard that we created that reports on all of the parameters that we're relying on inside of Power BI. So what percentage of the model elements have been assigned to CSI code? What percentage of the model elements have been assigned an estimate item name? And then the table in the middle is kind of a live table that updates based on whatever you click on. So if I start to look at, if I go to the CSI level 1 kind of pie chart there and click items that are blank, I can see that the only things that are blank are 2D detail items. I may want to dive into Revit and figure out exactly what these are, but understanding that they're at least 2D elements and not something in Assemble means I couldn't have assigned data to them anyhow. The next part is it's important to check the units of everything. So I will start to look at 5, 12, 23 structural steel across the entire project and make sure that every unit in that is tonnage. It's just a quick way to kind of filter the data how I want to see it. And then the last one that I'm going to show is what things have an estimate item name that's blank. And this is important because this is an Excel export that we used based off all the data that's either in each model or the entire project of Assemble to export that kind of goes straight into some of our estimates. So understanding things that we've assigned to CSI code but don't have an estimate item name is very important to us to understand that the data we're using and the data we're leveraging is accurate. So the next thing we're going to talk about is we kind of want to dive a little bit into some of the uses in the construction projects that we have going on. It's a little bit different than some of the data we've been using in pre-construction, but there's still a lot of value in some of this. So again, we kind of began with what did we want to get out of the system, what did we want to get out of Power BI, and really our goal is kind of what has been installed so far, what % complete are we, can we get an average production from each trade contractor for each material, how many days are left on the project schedule, and maybe what's the remaining duration based on the contractor's current production. This was just us kind of sitting down with our VP of operations, a couple different of our superintendents, project managers, and really kind of brainstorming what are the possibilities, what's possible, and really kind of what do we want. So from there, we had one project. They decided to kind of track installation of MEP through Assemble. I first told them, I said, I think you're crazy because it's not easy to select every piece of ductwork or every pipe on a project, but we talked about it. They wanted to do it because on their last project it was a challenge for them, so they wanted a better system and a better way. So I worked with them. I helped them get things set up. We used the Navisworks Publisher plugin for Assemble, which is very nice because you can filter basically what comes into Assemble. This is showing just ductwork, high pressure, low pressure, medium pressure supply, return, and then VAVs and mechanical equipment. We didn't pull in hangers, we didn't pull in diffusers, we didn't pull in insulation. We just wanted what we needed inside of Assemble, so it kind of kept our tracking database inside of Power BI a lot cleaner. The next step, and Tim and I were actually talking about this before the webinar, is you really got to set things up so it's easy for the field to use it. Creating views for each system on each floor so they can just open what they want to see on their iPads in the field and update a system at a time rather than seeing the whole floor will make it a little bit more easier for them to use and easier for them to populate the data. This really went a long way. The other thing that really helped our superintendent use it is just using a stylus on the iPad and learning about the multi-select. Being able to select more things on the iPad, it was a game changer for him, and he's loved it ever since. So the next slide, and this is kind of the important part. So as our superintendents are populating the data, we can report it kind of however we want. Do we want a % complete in line with our project schedule, or do we want to review a % complete of overall installation for each contractor? The good news is we can report it both ways, and it's free. All it is kind of just a different graph. So the one on the left is all ductwork. The one on the right is status of installation of each system across the entire first floor. However it is that we want to look at it, it kind of allows you to analyze the data the way you want. We had one project that was looking at this. They just wanted to track installation of chilled water because they needed to know when they were going to get permanent cooling in the building. Again, it's important to decide what it is that you want kind of early in the process and figure out a way to get there. The next thing, if you're relying on somebody else to enter the data, you kind of need a QA/QC process to check it. If you look at the dates across the bottom, they're fairly day by day, but you see the spike on May 17th that we updated a ton of ductwork that was installed. So if we're analyzing a piece count per day of ductwork that's installed, that's going to create an anomaly in the data. We can exclude that from the productivity count. There's different things you can do. It's just you need a process to make sure you understand what it is that you're looking at and the overall data that you're analyzing and what different kind of variables there may be within it.
I just want to highlight that statement. You definitely need to put a process in place to understand what you're looking at. And you've, in different dashboards here, you've talked about how you go about analyzing what information is incorporated, ensuring that all of, your Division 5 is all listed as tonnage of steel. With this, diving into removing anomalies and making sure you're looking at the right data. I think that's key, and I think that's something that's hard for a lot of people to get their mind wrapped around, but certainly the Assemble team can help with that and can help set up this kind of process to put this in place, and I know that you've worked with a number from our team to set this kind of thing up. So I just want to point that out because I know that is key to set up the right process to understand what the data is telling you.
Yeah, of course. So the next one, so while we have views for our superintendents for each system of each floor, we also created basically an entire floor overview so we could really kind of sit down with our scheduler, sit down with our owners, sit down with the design team, and really make sure that, again, we're all kind of collaborating on the same data set to track installation, to review payment applications, and understand our project schedule. This level of collaboration and kind of understanding has been incredible to watch. We have piping foremen and ductwork foremen actively asking to be part of this process and how they can update the data for us rather than us updating it, which maybe on the next project that's what we'll get. I would be super excited if that were to happen. So the next part, a lot simpler in concept than tracking the MEP installation, but very important to our project schedules to making sure we deliver the building on time is kind of how are we tracking the installation of the facade systems to make sure that the building gets complete. So this project is a 400-unit apartment complex, and they have 22 different facade materials across 11 different elevations. The first thing that we needed to do, or the first thing that we already had kind of from pre-construction, was in order to populate that facade report of the percentages of each material, we already had elements of the facade isolated. So that's this view. The next thing that we needed to do was, if we're going to drive schedule based off of each elevation, we needed to divide each the facade into the elevations that were corresponding with the drawing. So that was kind of step one that we did with the help of our VDC department. The second step is kind of making sure that all of those materials are still applicable. Was there any design changes? Was there anything that needed to change in terms of a cladding classification? We went through this with our project team, with the architect, and made sure that the cladding classifications we had applied back in pre-construction were still applicable to the job whenever they were going to install the facade. The final part, very similar to tracking the MEP installation. We're basically using a yes-no parameter to identify what pieces have been installed and what pieces are yet to be installed. This project team made the choice that they only wanted to track installation of finished materials on the facade, so we're not tracking studs, we're not tracking air vapor barrier, we're just tracking whether it has brick, metal panel, hardy plank, or whatever the finished material is, whether that has been installed yet or not. Here again, that was the team's decision. It's just understanding that decision up front allows you to structure the data and group the data in a little bit different ways. The first dashboard that we're going to look at can be reported. This is basically percent complete of each material on the building. Some people want to look at it this way. Some people want to look at it where you see the overall quantity of each material and what's been installed so far. This allows you to begin to kind of prioritize maybe your top 5 materials. Maybe you want to divide it by elevation and look at it a different way. I said it before, dashboards are kind of free in Power BI. Once you understand how to make them, you can group the data any way that you want to see it, whether it's the superintendent, the scheduler, the project manager, all the way to our VP of operations that might want to see a percent complete on all of the facade installation. It really comes down to just kind of how you want to see the data, how you want to group it, and then, like we said, having a process in place to kind of analyze the quality of the data you're looking at. One of the last ones, or another example, is kind of how do we use the data inside of Assemble, inside of our projects to really inform our schedules. So this is an example of an apartment complex. The original schedule was basically broken down by the buildings rather than broken down by each elevation. Our superintendent, our trade contractors, they wanted to kind of manage and drive the project based off of the elevation rather than having something 30, 40 days as a look ahead. They wanted to know what their deliverable was every 5 days, every 6 days, every 10 days. That smaller kind of manageable task list that you can get to and drive results from. So the first thing that we needed to do was we kind of grouped the facade elements that we had. Again, from our estimating phase, we already had the facade separated. We just needed to group it into each building. So we grouped it into A and building CB. The next thing, basically each elevation, we kept the roofing with this and just assigned the roof a different tag for location instead of elevation. But it really allowed us to basically take those quantities from the building A and B, the original contract schedule dates, and back out a contracted productivity of each contractor. From there, we could use that productivity and the quantities we were pulling from each elevation to get how long was the contracted duration on each elevation, really allowing us to kind of get some detail into our schedule, really start to plan in detail kind of how we were going to work our way around the building, different scaffolding shifts, different contractor moves, and really get into some detail of the project. So the last one, the last example that I have is kind of where we're headed, and I would not be here where I'm going to show without the help of Assemble. Tim mentioned it earlier, John Pryor has been a huge help to me throughout this. Especially this one. So with any project, what you really want to measure in terms of schedule is what was your original plan and where are you at against that. So we created a test project. We really wanted to start to analyze some of this data. This is a project that is well underway, but we went in, we entered a lot of data for every different steel sequence across the project. And we started to pull it into Power BI. I started on my own and tried to, if anybody's worked in Power BI and you've tried to overlay 2 different quantities over the same time, it is not easy and it is still racking my brain. But like I said, I worked with Assemble Systems. We got on a phone call and we were able to produce this graph. This is the planned schedule against the actual schedule for 4 different sequences of steel for that project. So it is possible, and like I said, it's always about continuous improvement, finding a way to be better, and this is our next step. It's not easy, but it's a challenge that we want to get to and make sure that we can use on every one of our projects moving forward. So finally, I think it's important to talk about lessons learned and things that I've gone through over the last, 2 years of using Assemble and Power BI. There's really things that you can learn to look for, learn to prepare for, and think about early rather than finding surprises. The first example that I have, so this is the project that we were tracking MEP installation based off the layers of the sheet metal contractor's model that they sent us. This is the rooftop ductwork model that is showing the roof, the air handlers, the fans, different mechanical equipment inside of either the supply duct system or an exhaust duct system. So it's really starting to mess with our geometry count. We're not truly tracking pieces of ductwork here because now we have pieces that aren't ductwork. We have risers that are documented in multiple models. You really got to find a way to either filter the data or live with it and understand that you're looking at data that's not 100% correctly. These are facts of life. You deal with these different things and you just got to figure out how to kind of work your way around it. Another example, so this is from the same project, the piping contractor. We reached out to him, we tried to ask him, is there a way to put the weld joints on piping on a separate layer? His response back to us was, no, I can't. So if you think about it, if we're analyzing the pieces of geometry that say yes, they're installed against the pieces of geometry that say no, they're not installed, in this picture, it's going to say that we're 66% complete with installation. Is that something you can live with? That's something that you got to know that you're at least making the choice. If you don't know you're making the choice, then you might believe you're looking at data that's 100% correct instead of data that might have a 10% plus or minus variance. The other thing you can do in this situation is if the superintendent is clicking on pieces of pipe and updating that they're installed, maybe a VDC person can go into the model and do a window select to catch some of these weld joints. It just comes down to understanding what are you looking at, what is the data truly representing. Data analytics can be a dangerous thing. You really got to have trust in the data that you're looking at and understand kind of the equations behind the scenes that are driving the data. So some of the big picture things, one of my favorite quotes is, data is nice, but structured data is powerful. So standards will help you go a long way. Come up with how you want to see the data. Don't just rely on Revit, because if you're relying on models from different designers, they're always going to have different naming conventions. Different designers use type name, different ones use type mark. Other designers have their own parameter. It's just, you got to have a way to normalize the data if you want to build your own database to kind of compare either over time or against models you're making your own or project to project. It's all about understanding what is your big picture goal and then kind of how you get there. So in summary, we'll talk a little bit about results. Assemble and Power BI have really helped us, definitely with takeoff time, quantity takeoffs. We've improved that process. The biggest thing that it has helped us with is really kind of trending reports and variance reporting over time. Like I said, a lot of times we will create models at different design iterations, and then we'll get a model or a drawing update from a design team. Being able to kind of go back and analyze any 2 points in time based off a couple different filters in Power BI is very powerful if you're sitting in a meeting with an owner. If you have to go back and pull out PDF drawings or go back and analyze different Excel spreadsheets or go back and whatever it is, go back into the office for a day, 2 days, you've lost that time, you've lost that moment and that opportunity with the designer, with the owner. So that has been a huge kind of positive feedback for IMC and our approach to kind of pre-construction. The soft side, I already touched on a little bit, decision-making, collaboration. We're leveraging the same data throughout multiple aspects of our company, throughout multiple processes, deliverables. It's really helped us manage our projects with a actionable data set that we can perform some analysis on. And with that, I think I am complete.
Awesome, Dave, and thanks for stepping through all that. I know this is content-heavy stuff, and I think it was fantastic to go through those different examples, but what you touched on there at the end, using data to collaborate around and make the right decisions is so powerful, and having that at your fingertips or providing that to your decision makers on a project, it's typically information that they would not have otherwise. And our industry is full of that kind of decision making around gut instincts, and having this data handy is so valuable for them to, again, drive that day-to-day conversation of the things that need to happen on a job site and understand how things progress in this context against the traditional process of managing and measuring what you're paying out to subcontractors on percent complete. So it's fantastic to see this as a new lens, as a different way to look at a project and add additional information to that. So we really appreciate you sharing what you guys have set up at IMC.